back, guys, to another lesson. In this video, we are going to cover Coulomb's law. We will first begin by talking about the subatomic particles, the metric system, some things that we need to know before we get to the calculations. And then we're going to go straight into the calculations, and last, we will continue with some practice problems. So let's go ahead and get started with the neutrons. So what I have here on the screen is a visual of the neutron. As the arrow points, we know that the neutrons are located in the nucleus of an atom. Its relative size is 1 and it has no charge. When I talk about relative size, it's just not its actual, if you were to measure a neutron, it's just in comparison to the protons, in comparison to the electrons, what would be its size. So for right now, we're just going with 1. When it comes to the protons, these also, just like the neutrons, are located inside of the nucleus. So its relative size is also 1. So what that tells us is that in terms of just the sheer size, the protons and the neutrons are roughly the same, correct? Because we're giving them the designation of 1. Now, when it comes to the charge, protons do have a charge. And that would be 1.6 times 10 to the power of negative 19 coulombs. So that's a really small number, right? Because it has pretty much 18 zeros. But when we talk about the charge, just know for right now that it is a positive charge. So last we have the electrons. As it shows here on the visual, the electrons are outside of the nucleus. They are located in the electron cloud. And when it comes to their size, they are 0.00054 in size. So what that roughly tells you is that they're about 2,000 times smaller than the protons and the neutrons. So they're really, really tiny, even by comparison to the protons and neutrons. Now, when it comes to their charge, however, they have a charge, and that charge is negative. So if you noticed, from the protons to the electrons, the value is the same for the charge. The only difference is that for the electrons, that charge is negative. So that's something important that we need to remember. So let's talk about some of the information that we're going to talk about, that we're going to cover here for the Coulomb's law. So I'm sure you guys have heard at some point in your life that opposites attract, right? So where does that come from? Well, it actually comes from a lot of different places, but when it comes to the information that we're covering here, we're talking about the charges. So as you can see here on screen, we have our positive charge and our negative charge on opposite sides. So what we have here is just two different particles that are opposite charges, and R represents the distance between them. So when we talk about opposites attract, we can see that the positive and the negative both have arrows coming out of them, and they are both pointing towards each other. That is a visual to represent that opposites attract. So whatever that force of attraction that is pulling them to each other, because they're opposite charges, right? Positive and negative, it's going to be what we're going to be calculating today. Okay, so opposites attract, positive and negatives. So on the bottom, on the left, we have a similar scenario, but in this case, we have two positives. And as you guys can see, we still have some distance between them, right? We don't know what that distance is yet, but we'll look at some examples. And we can also see that the force between the two is actually pointing away. And that is, again, because these two particles, these charges, are positive. So they're not going to be attracted, and therefore they're going to repel each other. So they're going to push away from each other, okay? So on the right side at the bottom, we have now negative charges. And just like the positive ones, they're going to have a force that is pushing, right? It's being pulled away. So they are repelling. And again, we have some distance in between the two. So opposites attract, likes repel. Okay, so let's talk about the equation that we have here. We're not going to go into where the calculation came from. That's way above the scope of our class. However, I do want to go through and talk about what each of the components of this equation represent. So what I have here is the generic one. So we have F, which is going to be the electrostatic force, and that is measured in neutrons. So that is that attraction or repulsion for that matter that I was just talking about here in just a moment before, with the little circles pushing or pulling away from each other. Okay, so that's the force. Now, the K in the equation, this one right here that I'm circling, that's Coulomb's constant. And remember, a constant is a value that doesn't change. That's one number that is established and that you will use in every single one of your calculations. So that's a number that we would definitely need to write down, memorize, or have it written down somewhere so that we can refer back to it later on, right? So then we have Q1 and we have Q2. What those two values represent is going to be the charges. So in every single example, you will be given both of those charges, or you might be asked to calculate for one of them. And those are the ones that we were talking about at the very beginning of the lesson when we talked about the positive and the negative, right? So our charges are going to be those two. Now, the R is the distance between the charges. Please do not confuse this R with radius that you usually see in geometry classes. Obviously, they're both measuring a distance, right? But here, we're not talking about the radius. We're talking about the distance between the two charges, the two particle charges that we're looking at here. And it's measured in meters. So before we move on, however, and that is squared, okay? Now, before we move on, we have to revisit the metric system, because right now here we have things like the meter and coulombs. So those actually, just like we have learned before, involve the metric system. So things like a kilo, a deci, a centi, micro, nano, they might come back into play because they are based on the metric system. So at any given point, any of our prefixes in the metric system can show up again. So we need to make sure that we remember this charge and that we have it available. In this lesson, however, we're really just going to focus on the nano coulombs. So that is going to have a magnitude of 9. And just a super quick recap, don't forget, we have our units. Those are our standards, right? And then we always have the orders of magnitude based on the metric system. You might be wondering, where did you get that 10 to the power of 9? Well, that is going to be based on the idea that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 orders of magnitude. So 10 raised to the power of 9. And the reason we do that, remember, that's back to the scientific notation. That's because we don't want to always write this down. 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't want to have to write that down every single time. So we definitely want to use our scientific notation, okay? So let's go ahead and do a practice problem, because that's honestly the best way to learn. So I have here the problem, we have the equation, and we have the constant. All we have to do is read the problem, figure out what is the information that is given to us, pull it into the equation, and then make a statement about what that answer represents. So let's read the question. Suppose that 2-point charges, each with the charge of positive 1.880 coulombs, are separated by a distance of 2.5 meters. Okay, so we were just told information, right? We were told that we have two charges and both of them have a positive 1.8 coulombs for the charge. And we were also told that there's a distance between them of 2.50 meters. Now, we are being asked to determine the magnitude of the force of repulsion. Notice how they're telling us you're looking for force, and it was also thrown in that they're repelling. Let's talk about that. Remember at the beginning of the lesson we said, opposites attract, likes repel. So because both of these charges are positive, so it's a positive and a positive, right? We said if they're the same charge, they're going to push, right? They're going to be trying to get away from each other. They're going to repel. They don't like each other because they're the same. So that's really what we're trying to figure out. What is that magnitude? What is that force that is being pushed away, right? So let's go ahead and put this into the equation. So we're looking for F, And we know that K is a constant. So this K will always be this value down here. So I'm just going to go ahead and write it in. And then I'm going to continue with Q1. And I know that Q is 1.80. So 1.80. And because we were told that there's two of them, right? I'm going to go ahead and multiply it by 1.80 again. And then I'm just going to continue on with my equation. I'm going to go ahead and divide that by my distance. And that distance was given to us as to be 2.50 meters. And because the equation has the distance squared, we're going to square that as well. So what we're going to do now, right, is going to plug all of this information into the calculator. And we will do after that is going to be make a statement about what this value that we just calculated represents. So what I'm going to do here in just a moment is going to be add a picture of my calculation on the calculator so you guys can actually see what it is that I plugged in, because I want you guys to make sure that we have that proper answer. So I put in 9 times 10 to the power of 9 times 1.8 times 1.8. And then I divided that by 2.50 raised to the power of 2. And what I obtained was a very, very large number. So I'm going to go ahead and write the whole thing. And that would be 1, 2, 3, 4, 5. So that is how many newtons we have. So these 2-point charges are repelling each other with this value for the newtons. Let's go ahead and look at another example. And I'm going to go ahead and walk you guys through this next one as well. Calculate the electrostatic force between 2-point charges separated by a distance of 0.98 meters. The 2-point charges are 0.65 nanocoulombs and negative 8.2 nanocoulombs respectively. Let's go ahead and begin with this problem. So let's begin by setting up our equation. So we are being asked to figure out the force, right, between the 2 points, and we're told that the distance is 0.98 meters. So we know 100% that whatever our force is going to be, we're going to have as the distance 0.98 meters, and that would be squared. We are also told that the charges are the following numbers, right? And that's pretty much it. That's what we're given. So it is up to us to figure out the rest of the equation. So we know then that K is going to be that constant of 9 times 10 to the power of 9. Notice how once again you have to utilize this particular constant, and you will use that value for every single one of these calculations. Let's go ahead and do Q1. Here, a lot of students sometimes ask, doesn't matter which one's Q1 and Q2. No, not really, because think about all you're doing is multiplying them, and it doesn't matter if you multiply 4 times 5, it'll give you 20. And it will also give you 20 if you do 5 times 4. So the order of the numbers when you multiply doesn't truly matter. So for the Q1 and the Q2, it does not matter which one is which. Just make sure you designate one as 1 and then the other one as 2. So let's go ahead and put in 6.5. Notice, however, that here on the question you were told that this is nanocoulombs. So what we need to do is multiply that by the order of magnitude that I was talking about earlier in the lesson when I talked about the metric system. So that would be times 10 to the power of negative 9. Now for the other point charge, that would be, negative 8.2 times 10 to the power of negative 9. And we know that because this is negative, Q2 and Q1 is positive. So we have a positive and we have a negative, right? And we know opposites attract because we just talked about that before. So we know then that there's going to be an attraction between these two values. So let's go ahead then and punch this into the calculator so that we can get our final answer for the static force between these 2 points. And like I said, I will go ahead and add a picture of what I am typing into the calculator into the video so that you guys are able to see exactly what it is that I'm typing in and how I'm obtaining my answers. So if you guys notice on the calculation that I put in, I didn't add that negative in front of the 8.2 because that's going to kind of mess up our calculation and it'll make it very complicated. So what I know then at this point is that because one of the charges is positive, the other one is negative, there's going to be attraction. So that force, that electrostatic force, is going to be this value for newtons. All right, so for this next example, what I'm going to do is I'm going to time you. And I'm going to give you guys about 2 to 3 minutes to calculate this by ourselves. Take the two examples that we've already worked on together. Go ahead and pause the video, work on this one, and in just a couple of seconds, I will go ahead and show you guys the full worked out problem so that you guys can compare your answers. Okay, here it is, the entire problem solved. Let's hope that this was the answer that we obtained. Make sure that you look carefully at the setup that we have here. Let's go ahead and move on then to our independent practice. And this will serve as your exit ticket or just honestly more practice for us to continue. The first question is going to ask you information about the relationship that we talked about in terms of the electrostatic force between charges. And also, the second question is going to just give you another example of a different type of calculation. So notice that in this particular example, I'm asking you to calculate for the distance, not for the force. However, we are going to use the exact same process that we have been using in the same equation. So now instead of looking for F, you're looking for the R in the calculation. So let's make sure we go back to some of those concepts that we have learned before in our algebra classes so that we can solve for a different variable. Thank you so much guys for watching, and in just a moment I will show you guys the answer for both of these two questions.